Hello, this is Sarfaz Niazi. Today I'm going to speak to you about a topic which is not under my domain, but I was asked by my grandchildren to explain to them, what is gravity. Now we experience it every moment we breathe. And I found that most people had big difficulty understanding where the gravity came from. One of my fellow colleague, Albert Einstein, had the same issue, but he resolved it. However, his explanation and those who followed is so complex. And I realized as a teacher from a lifetime that if I cannot tell you or I cannot teach you something that will make you understand, then the flaw is not with you, but with me. So I have put together a very simple explanation of what is gravity, using no equations, using no jargon, just the words to explain it. First of all, when we say that something is falling on the ground, there is a misrepresentation here. Nothing falls on the ground. The ground catches up to the object. So when Newton's apple fell, it was not that the apple went down to ground, the ground moved up to catch the apple. Example, regardless of what you throw from a distance up there, let's say you are 10 feet above and you throw a steel ball or you throw a very light wooden ball or a piece of wool, they will all fall to the ground in same time. It has nothing to do with what is their weight. And that can only happen if the ground is moving up to catch up with everything. So, the gravity that you and I feel sitting here on the chair is because the earth is pushing us up. Keep in mind, pushing us up, and therefore we feel the push. If you ever drive a car and take off very fast, you will see 2-3 G effect, means you sink into the seat, okay, because you're pushing yourself forward. So what is happening here is that Earth, our planet, is continuously going up, therefore pushing us up, and therefore we feel the force of gravity. But in a universe, there is no up or down. The fact is, the earth is round, so even though it's going up, okay, it's going around. So to us, it feels like going up, but to the earth, it is like going in a circle. So the first part of gravity I want you to understand is because the earth is moving and pushing us up to give the feeling that there is a force of gravity. Nothing falls. The earth catches up with whatever you have put in the air. Now the question arises that why the quote-unquote gravity is smaller on the moon compared to Earth. So first of all, the gravity that a planet produces, quote-unquote, is proportional to its weight. Now, this is where I think an explanation is needed. Okay. The space that what we call, you look around, is not quite an empty space like this. Okay. It's more like a trampoline stretched out. So if you take a heavy object, like let's say Earth, and you put it on the trampoline, this is what it will look like. It creates a bump, or I call it dimple, in the plane of the space. Now in this dimple, which I'm showing to you, if I throw another small ball anywhere in this dimple, the ball will go down and then start to circulate around the first ball that created the dimple, and ultimately hit this ball and stop. But what about if this dimple itself is moving at a very fast speed. So the small ball doesn't catch up with the larger ball. It just keeps moving all the time. So the universe is one huge dimple, and then there are dimples into dimples into dimples. The biggest dimple in our galaxy is the dimple produced by Sun. That's the biggest star. So it produces the biggest dimple, and there are small dimples because of Earth, because of other planets that we have. Our moon was actually part of Earth. It broke off and it got out and it started circulating around Earth because of the dimple produced by the Earth was bigger than the dimple produced by the moon. So the moon circulates around Earth. It is continuously falling into Earth. It's just never catching up with it because the Earth also moves. And same thing happens when we talk about the space lab and zero gravity. There's no zero gravity. In fact, the gravity in a space lab, which is only about 200 miles up, is not much different than you see on the ground. What's happening is that the space lab is moving at a speed which is faster than how the Earth is rotating. So it's falling down, but by the time it gets there, the Earth moves and it misses it and it goes around and around. But to have this, okay, the lab has to have a certain speed. So when we go up in the space, we need a rocket because we're going to go with very fast speed. And then when we go where the atmosphere is zero, we develop certain speed which will keep us in the circle. And then we switch off the engines. There's no resistance to flow in space. So whenever we switch off the engine, that speed maintains. Sometimes we have to fix it. As long as our speed is fast enough, so we miss out hitting the Earth. So we're continuously falling, and you think about it as an opposite of what I said, if you're continuously being pushed up, okay? So we feel a zero gravity. So in summary, gravity is what we feel sitting on Earth is because the Earth is pushing us up. There's no up and down in the space, so we're just moving around and we keep feeling the same gravity all over. The different speed of the movement creates a different gravity. Because if it's moving fast, okay, then it's pushing you harder. And that depends on the weight of the object or planet. Okay? Earth is heavier than Moon, therefore Earth has more gravity than Moon. Sun is heavier than Earth, so it has more gravity than Earth. So the Earth goes around Sun and the Moon goes around Earth. That is what everybody has tried to explain. But I thought I should give it to you in a simple words. I hope you understood it. I hope you appreciate it. Because these are the fundamental concept of universe. Space can be warped. This is called space warping, when this little ball is sitting in there and creating a dimple. And it is a space warping that creates everything that we call in astrophysics. Okay. Can we go around and compress the time? Yes, we can. Because if you fold it, if the two stars, one here and one here, and you know the distance, but if I fold the place or this plate, then I can reach them almost instantly. So if the space converges, think of a space as a flat sheet, a flexible flat sheet, which is bouncing off all the stars, creating the dimples, and every other star or planet is rotating around because it keeps missing it. It's got its own dimple. So it's a dimple into dimple into dimple until we have the huge dimple, what we call the universe. I hope you liked my explanation. My grandchildren liked it. They're still questioning a lot of things, but at least I was able to explain to them using no equation, no jargon, and no confusion about how it works. I hope you enjoy it. Have a nice day. and stay on the ground. Have your feet on the ground. Let the earth do the job. Stay firm. Thank you and good day.